This is section 9.3, part 2. Alright, so last time I indicated that there were written directions, guidelines as to how to graph y equals a sine of bx or y equals a cosine of bx, noting that in this book b will always be positive. So there are those 5 steps which you can read, and what I want to do is I want to go through an example to talk about all of those changes and things that we would do. So I actually don't do it in quite that order, but I guess I'll do it that way. It doesn't hurt. The order in which you do some of these things doesn't really matter that much, at least for A and B. When we pull in C and D, you have to be careful about the order more. But these two are sort of interchangeable. But this time, at least, I'm going to follow those steps, and then the next one I do, I'll probably revert to what I normally do. Because basically what I do is I do them alphabetically. I think about A, then I think about B, then I think about C and D. Anyway, usually. So, they say to find the period. So, we'll do that first. First, the period is going to be their normal period for sine, which is 2 pi, divided by the absolute value of b. Since b is always positive here, we can just say divided by 3. Then, for step 2, I would then divide the period by 4. So 2 pi over 3 divided by 4 simplifies to be pi over 6. And so what that means to me is that when I go to graph this, on the x-axis, I'm going to make a mark every pi over 6. So the spacing of the marks on this look the same, whether it's pi over 2 or 2 pi over 3 or 7 pi over 73 or whatever. I always make them about the same size. It's just the label of that first mark makes this specifically this graph. So I make a mark every pi over 6. So they say mark all by values. Yeah, okay. What I think, I know it says sine starts at the middle value, cosine starts at the high value. Yeah, that's true. But what I think about is, okay, if I have 0 and I put it into the equation, 3 times 0 is 0, sine of 0 is 0, 0 times negative 2 is 0. So I'm going to plot that there. If it had been cosine, I would have done the same thing, but I would have gotten either a high if a is positive or actually a low if a were negative. Because if that were cosine, cosine of 0 would have been 1. Negative 2 times 1 would have been negative 2, and we would have started at the low instead of the high. Okay, now looking at the amplitude. So I guess I've done 3 over there on the graph. So I'm not going to write the number 3 and just say that we've done it. Or I'll say 3C graph. And then later that won't make sense because there'll be all kinds of things on there. But oh well. Anyway, hopefully you understand what I'm saying. We're supposed to then use the amplitude A to graph the points. So the amplitude will be the absolute value of negative 2, which is 2. Which means the high value is 2 and the low value is negative 2. So I'm going to make sure that I mark on my y-axis at least 2, maybe 3 marks, so that I don't end up regretting what I've chosen to do and go, oh man, I need to go a lot higher than what I gave myself. Oops. I don't want to do that too much. Okay, so in number 3, it said where it starts, but it didn't really tell you how to find the next point. Since it's sine, normally we would be going to the high value of 1. That high value will be multiplied by negative 2, making the output negative 2. So it's actually a low value. Oops, I meant for that to be a different color. Let me just change it to that color. So you're going to have to pay attention to the negative because sine normally starts at the middle and goes to high. If it's a negative a, you're going to go to the low instead, after the middle, at 0. If we're talking about cosine, the difference will be, instead of starting at the high when a is positive, as I said earlier, if a is negative, you'll start at the low. So that's the major change that that negative has. Then once you get started, once you have these first 2 points, you're actually well on your way, because after middle, low, the next thing has to be middle, then high. Make sure you use the amplitude and go 2 above the middle. Middle, low. Make sure, again, we're using the amplitude correctly. And then you can go the other way. High, middle, low, middle. And if you've done a graph to the left side of the y-axis and a graph to the right side of the y-axis using what we've been talking about, and have at least 4 marks on the positive x-axis and at least 4 marks on the negative x-axis, then you'll have at least 2 periods. Actually, I went a little bit further than necessary here. Of course, the graph does continue on. I haven't been drawing that in, but it continues forever in that same pattern. So I'll draw a little bit extra and put a little arrowhead on it to say, yep, it just keeps on going. So there's that graph, and it wasn't that painful. And 5 was draw the graph over additional periods as needed. Well, I did that automatically because I went to the right of 0 and then backed up and did the pattern to the left side. And so I'll say see graph again. My talking through is actually more of an indication of what's going on in my head than what I'm writing over there to the left. So let's do another example of that so that you get an idea of what I actually go through when I'm doing one of these. So let's make this y equals -3 cosine of 4x. Okay. And this is what I'll actually do when I'm doing one of these. I'm going to look at the a value first, which gives me the amplitude. The amplitude is the absolute value of a, so the amplitude is 3. If you want to, because a is negative, you might want to write yourself a note that you're reflecting vertically so you don't forget when it's negative, because that's real easy to go, you start graphing just to forget to do the reflection. So making yourself a note like that won't hurt. Then I'll find the period by taking 2 pi and dividing it by the absolute value of b. The absolute value of 4 is 4, and so the period is pi over 2. Then I'm going to divide the period by 4 to get the horizontal distance between the major events, the middles and highs and lows and all that stuff. Will be spaced every pi over 2 divided by 4, the period divided by 4, so every pi over 8. Okay. After I've done all of that work, which I would want you to write all that stuff down anyway, in the directions I'll ask you to find all of those things, and I'll be looking over on one side or the other for a listing of all those things and the answers to them. So the period over 4 tells me how to mark my x-axis. I'll make 4 marks to the right and 4 marks to the left, which will give me 2 cycles, so that's good. My amplitude is 3, so I'm going to make sure I show at least 3 marks, maybe more. I tend to give 1 more than needed, but that's just a habit. Okay, now we're ready to graph. So I think about 0, and I actually substitute it in to the original equation. 4 times 0 is 0, cosine of 0 is 1, 1 times -3 is -3. So when x is 0, I'm going to graph -3. So instead of starting at the high, we're starting at the low, and that's because of that negative. And that's done the reflection for me. I think I'm good. So after high will be middle. I'm sorry, after low will be middle, then high. Don't forget that the height is an amplitude of 3. So make sure you go 3 above the x-axis and 3 below the x-axis. And do your middle, high, middle, low, etc. And then do your best to draw a sinusoid these are curves, not lines, and so try to make them look curved instead of linear. Do your best. And that's the graph. Okay, so now we're going to get into C, which this book for some reason calls it D. I'm not sure why they changed that letter, so I'm going to do it the way that I think is better, which unfortunately is going to make some of you a little bit upset with me, and I'm sorry. But this is the way that it's taught in a lot of college algebra texts, and so I'm going to kind of stick with that because I think it's a better notation than what they're using. I call this C, they call it D. What you really need to know is because it's with X, it's going to be a horizontal effect. And that negative is supposed to, that minus is supposed to remind you it does the opposite of what you think. So what that does is it shifts or translates. Translates is kind of the nicer mathematical terminology. It translates the graph of y equals f of x, the basic graph, C units. If C is positive, so for example, if I had, let's write a positive one over here, like if I had y equals x minus 2, where 2 is a positive number and it's subtracted from x squared, that would actually shift the graph of y equals x squared. You think because it's subtract 2, you're going to make the x's smaller, which would shift it to the left. Remember, it's always counterintuitive for the horizontal transformations. It actually shifts it to the right when C is positive. So when C is positive, you'll shift to the right. And when C is negative, it'll be to the left. Let me show you what that looks like. If I had like y equals x minus negative 3, so C is a negative number, right? Well, most of the time you'll see x minus negative 3 written as x plus 3. And that will shift the graph of y equals x squared to the left 3 units. So what I tend to think of when I see plus a number, I'm going to think, I feel like that should make it go to the right. It actually goes to the left. And when I see minus 2, I think that feels like it should move left 2. It has to go to the right. So every horizontal effect does the opposite of what you would have thought. And that's why it's defined as subtraction. So to kind of remind you, it's got that opposite effect. Now, in trigonometric graphs, that translation has a name. It's called a phase shift. That's a horizontal shift in the graph of a trig function. It's called phase shift. And the part that's labeled x minus c, the thing that's inside, so over here it would be x minus 2 or x plus 3, that's called the argument. So that's what you're taking the sine or cosine or whatever of, or doing the squaring to. That's the argument that you're doing that to. It's what's inside the parentheses of whatever your function statement is. Okay, and that gives us a phase shift. So, for example, if I had this graph, let's see, y equals sine of x minus pi over 3. I'm going to go ahead and do everything on this one because it gets you prepared for thinking through everything if you do it every time. So the amplitude is the absolute value of the invisible 1 in front of signs. So the amplitude is 1, so that's normal. That's what you'd expect. The period is 2 pi divided by b. b is the number in front of x. It's an understood 1, so the period is still 2 pi. And we'll divide the period into 4 equal parts. That will allow us to put the marks on the x-axis at the spacing we'll need. So this does get a little bit uncomfortable when you're shifting, though. I will tell you that it's kind of awkward, and you'll see why in a second why I'm saying that. So this is the spacing between highs and middles and lows and all those things that happen. And I'm going to graph the regular sine of x function first, so that you can see what's happened to it. So starts middle, high, middle, low, middle. And I'm just going to graph one period. This actually in the direction says just graph over one period. So that's all we're going to do, is that one. So to graph the one we were asked to do, which is going to be in this color, we're going to take every single point we just plotted and move it. And I should have written this down here below. I forgot to do that. We're going to shift, or translate if you prefer, pi over 3. Oh wait, I'm sorry, hold on. I want to use the vocabulary that they use, so don't write shift. My bad. They're going to ask you what's the phase shift. The phase shift is going to be pi over 3 is the distance, and since it says -3, I feel like it should be left, but it's actually going to be to the right. Now, in my math lab, when you're doing these exercises, if it's to the right, they want you to put a positive number, put pi over 3 for this. I, however, want you to write the word to the right, so that when you're doing this for me on a test, that makes me realize that you actually know which way you're supposed to be going. So in the homework, I'm sorry this is different from what I'm going to expect, but if it's a x minus a number, in the homework you'll see that number as a positive number. If it's x plus a number, they'll want you to write negative that number. So if this had been x plus pi over 3 in the homework, on my math lab that is, for x plus pi over 3, they expect for you to write negative pi over 3. I would want you to write pi over 3 to the left, or just pi over 3 left. So that's a major difference, and I apologize for that, but I really think what I'm asking you to do is more informative. They're just kind of sliding through and making it a positive or negative number, which I guess it does make sense. I just prefer my way. Anyway, let's move all of those points pi over 3 to the right. So you're going to have to envision where pi over 3 is. This is what I was trying to indicate a second ago when I said this is kind of awkward. If that's pi over 2, I'm going to guess where pi over 3 is. Thinking about this is where pi is. So pi over 3 is a third of that. So I'm going to think about a third of that, and that's about right here. And I'm going to move that first point, pi over 3, to the right. So I'm going to move this point, pi over 3, to the right. Every one of them is going to be moved pi over 3. I'm still dealing with the major points, the highs and middles and lows. I just have to shift them over a consistent pi over 3 amount to the right. And then once you have your 5 points, 4 regions, 5 points, you graph the sinusoid along those 5 points, and you can now see very clearly that the green graph, the original sine of x graph, has shifted over to the right and the distance is pi over 3. And since that's a guess on my graph, that's why it's so important for you to write what it is you're doing over here, so that when it's not on a mark, I can tell what you meant to do. Even if you happen to accidentally do it in not quite pi over 3, which I'm sure if you measured mine, it's not exactly pi over 3 either. Then I'll know that was your intention, and you can get a lot of credit for knowing what you're supposed to do. All right. So then the next thing that we're going to deal with is vertical translations. And what that will look like is y equals f of x plus d. Did I write it generically like that, or did I just use sine of x? Oh yeah, I did f of x up there. Okay. F of x plus d shifts or translates the graph vertically. And if you think about it, that makes sense, because you're getting the output for your function and then adding something to it. So you're adding to the y value that f of x would have given you. So if you add to the y value with a positive number, that's going to move it up. And if you add a negative number to it, that's going to move it down. So when d is positive, it shifts up. And when d is negative, it will shift down. D units, I should have said. Thought it, didn't say it or write it at first. So anyway, that's what that's going to do. And that's actually one of the easier ones to understand. So I'm kind of glad they left it to last, because it's really not that bad. Now, the word that I'm going to apply to this is baseline, and we'll apply this pretty soon. The baseline will be in our list of things, so we're going to have amplitude, period divided by 4, phase shift, and baseline. Those 5 items are going to be addressed in every one of these, and that's one of the things I want you to kind of keep in mind, is that these are the big ideas. And the baseline, we're going to then put a colon and put the equation of the new baseline, which will be y equals, it'll be a horizontal line, y equals d. And I'm going to put that into action with an example so that that's very clear what I mean by that. So let's say we're doing y equals sine of x minus 1. Okay, so doing everything. The amplitude is the absolute value of the invisible 1 in front of sine of x, so that's 1. The period is the normal period for sine of x, which is 2 pi, divided by b. b is the invisible number in front of x, which is 1, so the period is 2 pi. Then we'll divide the period by 4. 2 pi divided by 4 is pi over 2. So that's the spacing on the x-axis. Mark every pi over 2. And like I said before, if you put 4 marks on either side, you're bound to have created plenty of space to have created at least 2 periods of the graph. Okay, the next thing is phase shift. You have to be kind of careful here, because if there's going to be a phase shift, it's actually going to be written within parentheses. And this is kind of awkward, because it's kind of an understood thing that if I have y equals sine of x minus 1, that's different from y of sine of the answer to x minus 1. Those are different things. And this would be a phase shift, because it's inside of the parentheses, subtracted directly from x before you ever take the sign of anything. But in the first expression, and there are no parentheses, so that's what makes it a little bit awkward, you're going to take the sine of x, get an answer, then subtract 1. For clarity, and this isn't going to be written in books, so you just need to get used to it. For clarity, you could put the x within parentheses to make sure that you take the sine of x, get an answer, then subtract 1 from that answer. But I'm just telling you that you're not going to see those parentheses all the time, and so you're going to just have to know that that's what that means. One way that they clarify this in the book is a lot of times, not every time, but a lot of times they'll write that in front so that there's no question as to what you're taking the sine of. You're taking the sine of x and you're adding -1 to it, okay, which is the same thing as sine of x minus 1. But since you're going to see them in this form over here sometimes, you kind of need to get used to it. That's going to be assumed to be a vertical translation unless it's inside the parentheses like over here. Then it's a phase shift. So make sure you understand that distinction. Okay. So anyway, back to phase shift. There's nothing subtracted from x before it goes into sine, so the phase shift is 0 as a number. You could also say, instead of phase shift equals, you could say in this case, no phase shift instead, and that means the same thing as. So either one of these two phrases. It doesn't really matter to me. In the homework on my math lab, it'll be 0. They're looking for a number. I'm okay if you say no phase shift. It means you've addressed it and you know nothing's happening to shift it left or right. So that's good. Now the baseline. Is going to be y equals d. D in this problem is -1. Remember, this is defined up here as f of x plus d. And so -1 is the same thing as plus -1. And so y equals -1 is our baseline. So I forgot to draw anything over here. Actually, I didn't forget because I was sort of waiting. Because you've got to figure out where your baseline is and think about your amplitude before you make the marks on your y-axis. You have to think about all that. So what I'm thinking in the background is this. The baseline is at y equals -1. So I'm going to draw a dotted line on my graph, a horizontal line at y equals -1, and that's our baseline. What the baseline acts as is a new middle. The whole graph is being shifted, in this case, down 1. And so that means that the middle values will now be 1 below the x-axis. And so by drawing this baseline at y equals -1, it's a location for my middle values. So you have to really pay attention when you're doing this graph. So I'm thinking, first of all, at 0, sine of 0 is 0, -1 is -1. And notice that sine of 0 is giving me an answer on the baseline. So that's at the middle right now. The next mark is up because I don't have a negative a, it's +1. So I'm going to go up. And how far up? The amplitude is 1, so I'm going to go above the baseline 1. So the amplitude is how far from the baseline. It's not giving you the actual y value. The actual y value here is 0, 1 above the baseline. So middle, high, middle, back to the -1, low, 1 below the baseline because our amplitude is 1, happens to be a y value of -2 there, but more importantly for graphing purposes, it's at the low value is amplitude 1 below the middle line, okay, and then middle. Then going the other way, it'll be low, 1 below, middle, high, 1 above the baseline, middle. And that gives you your sinusoid. Points, major points on your sinusoid. You just draw your sinusoid in, and you're done. All right, so Now let's graph one that's a little bit more complicated, one that has more stuff to deal with rather than just one thing at a time. Let's do 2 things, 3 things, 4 things, whatever this one has in it. We'll see. So y equals 3 minus 2 times the cosine of 3x. All right, so amplitude is the absolute value of the number in front of the trig, or not any trig, but cosine or sine function. So -2, the absolute value of -2 is 2. So our amplitude is 2. We're going to be graphing 2 above the baseline and 2 below the baseline. So when we go to make our y-axis decisions about where our marks are going to be, keep that in mind. Our amplitude is 2. Now, because a is negative, you might want to write yourself a note that it reflects vertically, okay, because it's negative. That's something you're going to have to think about. Okay, period is 2 pi divided by 3. Then the period divided by 4, which is actually more important. You have to find the period to do this calculation, but it's the period divided by 4 that we actually use. Anyway, that's pi over 6. So I'm going to go ahead and start my graphing. As soon as I make that decision about what period over 4 is, I'm going to go ahead and make the marks on the x-axis every pi over 6. Okay. Phase shift. Do you see that that x doesn't have anything directly subtracted or added from it inside of parentheses before you take the cosine? So that means that there's no phase shift. And remember, in my math lab, that's probably going to be phase shift equals the number 0. Okay. And then the baseline is the number added to the output, -2 cosine of 3x, whatever that output is. We're going to add 3 to it. So that means that our baseline is at y equals 3. So that means that I'm going to have a horizontal line at y equals 3. And because my amplitude is 2, I'm going to have at least 2 marks above that and 2 below it. So notice that I probably could have made my x-axis a little bit lower and made my graph have less quadrant 3 and quadrant 4 blank space, because I'm not going to use that stuff down there, and made quadrants 1 and 2 a little bit bigger. But that's okay. I mean, sometimes you don't think about things on time, and that's not a big deal. All right, so the baseline is y equals 3. So at y equals 3, draw a nice horizontal line. That's your baseline. There's no phase shift, so I don't have to worry about that. So starting at 0, cosine of 3 times 0, so 3 times 0 is 0. Cosine of 0 is 1 times -2. 1 times -2 is -2, plus 3 is 1. So notice that if by doing that substitution, we can check that, because cosine normally starts at the high. But because the vertical reflection is happening, it starts at a low instead. And how low? Well, the amplitude's 2, so that low point, notice, is 2 below the baseline, which is good. So the next mark over will be the middle. Next mark will be the high. How high? Amplitude 2, so 2 above the baseline. Then the middle, then the low, again 2 below the baseline. Then going this way, it'll be middle, high, middle, low. And if you can keep track of the amplitude like that, be very careful that you do that, you're bound to have a pretty good graph if everything else is working out That's a really nice thing to make sure you don't mess up, because it's really easy to do it. Oh, high is always 1. No, it's not. Not if the amplitude's 2. You make the high 2 above the baseline, the low 2 below the baseline, as we have in this one. All right, so that's what that looks like. Okay. So, and then they have some guidelines about, written out here, how to do all of the steps, and it's basically what I've done on every problem since I've started writing everything down: amplitude, period divided by 4, phase shift, and baseline. That's what I've been thinking through and doing. So you can read through those steps, and they're very valuable, especially when you first start and you can't remember exactly what I said to do. Those are a good thing to rely on, to think about. But this is how I would do this kind of problem, is go through those steps. And I'm not going to actually look at the steps. I'm just going to do the problem. But you'll hear me saying every one of those things in some form or fashion. We'll deal with all of them. Okay. Oh, I see a problem with this one already. The generic equation I wrote way up there at some point, maybe it's in the last part, was that I have A times F of B times the quantity X minus C plus D. I wrote this a long time ago. And the thing about this BX minus C, which I didn't read it correctly, but the thing about that is C is only the phase shift, or the horizontal shift if you want to think in a college algebra setting, if the coefficient of X in front of it is 1. So the phase shift here is not pi, because the coefficient of X is 4. So to actually see the phase shift, if you have a coefficient on X inside the parentheses, you're going to need to factor that off. So factoring off the 4x divided by 4 leaves X, plus pi divided by 4 leaves pi over 4. And that number, pi over 4, is giving us the phase shift distance. Not pi, it's pi over 4. So this is something you're really going to have to look for, is the coefficient of X has to be 1 inside the parentheses, so that the number behind X that's added or subtracted is the phase shift. And so we have to do that factoring in order to get that done. So let's start with amplitude. It's the absolute value of the number in front of sign, absolute value of A. That's 2. Since 2 is positive, there's no reflection. We don't have to worry about that in this problem. The period is the base period for sine, which is 2 pi, divided by B, which in this problem is 4. So that's pi over 2. Then I'm going to divide the period by 4. Getting pi over 8. And so I can go ahead and start with my graphing. Oops, didn't draw this way enough. I can go ahead and decide to make every mark on the x-axis worth pi over 8. Keep in mind, this is a willing distortion on my part. Normally, if the marks were pi over 2, I would have only made a mark by the fourth one here, 4 pi over 8, the furthest one on the x-axis to the right that I've drawn. That would be the first mark, and I'd have to be worried about making changes every quarter of that mark. And that's why I like to do the period divided by 4 and intentionally distort the graph. And I'm perfectly okay with that because it makes it easy to graph. And it is accurate, so that's good. All right, so the phase shift, make sure you look at the factored form. I see a pi over 4, so that's the distance I'm going to move. And I see a plus in front of it. My gut reaction is I should move to the right because it's plus pi over 4, but my inclination is always backwards. when it's horizontal stuff, like left and right stuff, it's actually going to move to the left, pi over 4 to the left. And keep in mind, in my math lab, I'll write this parenthetically, they'll want you to write negative pi over 4 in. Instead of saying pi over 4 left, that's what they want. And that's okay in the homework and quizzes. You can do that. But on my tests, make sure that you're using the word left or right. And the phase shift will be a distance, so it will always be a positive number, and then the word left or right will tell you which way to go. Okay, and then finally the baseline. The number added or subtracted there is -1, so the baseline will be at y equals -1. So that's where I'm going to start graphing, is the baseline of -1. So this is 1 up here. So this is at -1. And in my mind, I'm also, before I start making any marks, I'm also thinking about amplitude. I didn't express that out loud, but I was thinking amplitude 2. So from my baseline at -1, I have to show marks that go at least 2 above that and at least 2 below it. And like I said, I a lot of times go an extra one, but I didn't this time because I didn't write the y-axis, the negative y-axis long enough to have an extra mark that I won't use, but that's okay. So now let's go with 0. This is everything. So this is what I think through. Think about this very carefully. For sine, at 0, I would be at the middle value. So on the y-axis, I'm at -1 at the middle value. I don't know if you can see my cursor kind of hanging out there, but I'm looking at this place right here. That's where my focus is to start. Okay, because it's sine, I'll start at the middle value at the y-axis. Then I have to think about my phase shift. My phase shift is pi over 4 to the left. You have to think here very carefully. If the mark is pi over 8, how big is pi over 4? Well, isn't 2 pi over 8 the same thing as pi over 4? So if I'm going to move pi over 4 left, that's going to be 2 marks to the left, and I'm going to put my middle value right there, and that'll get me started. Okay, that's my middle value that's been shifted left, pi over 4. That's move left pi over 8, move over another pi over 8 for a total of 2 pi over 8, which is pi over 4. Okay, so the next thing I have to do is think, well, is it reflected? No, because 2 is positive in front of sine. So the next thing after the middle I expect is that my next mark over to the right, I'll be at the high. How high? 2 above the baseline. Next mark, I should be back to the middle. Next mark, at the low. How low? The amplitude 2 below the baseline. Then middle, then high, then middle. Then going to the left, low, then middle. So here's our sinusoid through the points I've plotted. And I go a little bit extra so that you know that it actually does continue. And there you go. There's the graph. It's a detailed, very involved process, especially if you don't have everything as sort of insignificant. If you're multiplying by 1, there's an invisible 1. It's kind of like it doesn't have that big of an effect. If you're adding or subtracting 0, it's not an effect. But when every one of these is a non-trivial number, not 1 or 0, like this one that we just did, then you have a lot of thinking to do, and it's a lot of complication. So please be aware of all the steps that we're going through to get these graphs so that you can do it as well. Okay, the next example is how this is used. in kind of real world situations. You may remember that I was talking about, when we were first talking about periodic functions in the first video over this section, I talked about temperature as being a periodic thing. You expect it to be, for high temperatures, maybe in the hundreds in Texas in the summer, maybe in the 70s, 80s in fall, maybe average about 40 or 50 in the winter. In the spring, maybe 60 or 70. I'm just making up numbers. And then summer, you're back to the hundreds. So it's going to do that year after year after year with slight fluctuations. Real data is never perfect. It's going to be messy, but it's something we can model and use to predict what would happen at a certain time of year if you have a model, an equation for the temperatures. So let's read the problem and make sure we understand. The maximum monthly average temperature in New Orleans is 82 degrees Fahrenheit, and the minimum is 54 degrees Fahrenheit. Okay, so this is the monthly average temperature. Okay, so in the table below, they have for each month what the temperature is. I don't know if that's a high or a low, but it's the average temperature during all the days in January. I guess that's what that means. So when you see that data, which I hope you're looking at it, because I don't want to write it all down. It'll take too long. And it'll bore you for me to write it if you can look at it there. What they've done, and I hope I put this in there, is next to that you see a graph from a graphing calculator of a stat plot of every month what that temperature is. And so notice that at month 1, January, it's plotted something at about 50. Because the low is 50, the high is 85, and so it's actually graphed 54 for month 1. And month 2, they've graphed 55, etc., etc. So, let me sort of, I'm going to sort of graph that. Not very perfectly, but sort of get the idea of. So this is sort of the graph you're seeing. Okay, and this is over a 2-year interval. So this is actually 2 cycles, 2 years worth of information that they've plotted. We only need one of them. Actually, you only really have to have half of a cycle to figure everything out. But nevertheless, so the directions say, for part A, to use only the maximum and minimum temperatures, determine a function of the form f of x equals a sine of b times quantity x minus d plus c. Remember, I have c and d backwards from what they have, where a, b, c, and d are constants, that models the monthly average temperature in New Orleans. Let x represent the month with January corresponding to x equals 1. That makes sense. October would be 10, right? December will be 12. 13, that's January of the following year, just so you know. That's how that would work. So, using only the maximum and minimum temperatures. Well, they said that the maximum is, right here, the maximum is 82 degrees Fahrenheit. And the minimum, right here, is 54 degrees. Okay, well, if that's the max and that's the min, what can we find out? Well, one of the things we need to find out is where the middle is, because we've got the highs and lows, and the middle is very important when graphing these. Okay, so the middle, if 82 is the high and 54 is the low, what's right in the middle? Think about, how do you get the middle number? Like if you had a test grade of 90 and another test grade of 94, how would you find the middle grade? You need average, right? So this middle number is the average of the high and the low. That makes sense, right? So let's see, what is that? 136. So half of that is 68. Did I get that right? I should probably pull up my calculator and double check that I'm not messing up that number. Yep, that's right. Okay, so that's where our baseline is. Y equals 68 is the equation of our baseline. And what that means is that in my thinking, the way I do this, which I'm going to write that down again so that there's no confusion of what I mean. They said to use a sine function, so I have to use the sine. I'm going to tell you that when it's my preference, when I get to choose, I always use cosine. But they told me use sine, so dang it, I'll just have to do it. I use b times x minus c plus d. And where I have the c, they have a d. And where I have a d, they have a c. As long as you get the number right, that's what really matters. So that number has to go in the right spot. So for my thinking, this means that d is 68. For them, c would be 68 because they switch the c and d letters. Okay, so we've gotten the first of 4 things we had to find for this equation. Not bad. Okay, so what's the amplitude? How far is it from the middle to the high? Remember, the middle is now known to be 68 degrees. How high is that, or how much of a change is that? Let's see, that would be 14 degrees, right? Yeah, that's 14 degrees. From middle to high is 14 degrees. And so what that means to me is that A is 14. Now, it could be that A is negative, but when you're coming up with a model, never assume the harder situation. So we're going to assume that A is going to be positive unless there's a compelling reason to make it negative. Like they say, you must use a negative number for A. Then we'll be forced to. But if it's your choice, go with the easier thing. So I'm going to assume if the amplitude is 14, that A is positive 14 because it's easier that way. Okay, now, what is the period? How long is it before we start repeating ourselves? Okay, think about this. This is real world. This happens every often? Every year. And since our x values are not numbered by years but by months, the period is how many months? 12 months, right? The period is 12. So that does not give me b directly. This is the hardest part of this, to be quite honest, is finding b. You can identify the period, but you have to remember that the period is calculated by taking the regular period for sine, which is 2 pi, and dividing it by the absolute value of b. And again, we're going to assume b is positive, so I'm just going to put b there. Then you can multiply both sides by b, and then to solve for b, divide both sides by 12. Dividing both sides by 12 gives you pi over 6. Okay. Oh, and I want to show you something there. I don't know if you noticed it on your own or not, so I think this is worth saying. If you have a number, let's say it's a, equals some number, let's call it b, over x, where x is the thing you're solving for. When it looks just like that, the quick way to solve that, which always works, is that the a and the x can just switch places. This will help you on a lot of calculations to be really fast. The a and the x can just switch places. Look at 12 equals 2 pi over b. There's the 12, there's the b. Here I've switched places. So I don't really need this middle step that I put a check mark next to. I mean, you can do it. It's not a problem if you do. But if you see this as a shortcut that you can put to good advantage, then do so. All right, what have we not talked about? We have B, we have A, we have my D, which they call C. We don't have my C. That's the phase shift. So what we're going to have to come up with is how far are we moving this graph horizontally to get it where it is. Well, if you think about this being sine, the middle value is what we get for sine of 0. So it's this value on the way up, because remember we assumed that A was positive. So we want the one that's at the middle on the way up. I would not want this one because that's the middle on the way down. I could use that one, by the way, if I wanted to, if I made A negative. But remember, we're making A positive to make this as easy as possible. So not that one. You want the one I circled. So you need to see, well, how much are we shifting that over to get there? This is why I don't like using sine. I don't see 68 in there. Do you? I don't see 68 in there at all. And so they're making it harder on us by forcing us to use sine, because we have to calculate somehow what that's going to be. How far over? And since 68 is not a data point, we're going to have to guess. And what they say in their solution is trial and error leads to D equals 4.2. Well, that's my C. So they're going to say that they're just going to sort of wave their hands and say, voila, we've just made up this number. I don't know how I got it. I just did trial and error and it looked pretty good. I don't like that. So I'm going to go back and do this problem with cosine, which is the better way to do it. The good news is all the thinking we've done is not wasted. Okay, so a lot of the stuff we just talked through is the same discussion. There's going to be one minor change, but let's write the equation they wanted us to come up with. That 4.2 is quite, I don't know how they got it, is sort of my gut reaction. So anyway, y equals A was 14 times the sine of parenthesis B, we got pi over 6 for B, times the quantity, so another parenthesis, x minus C, my C, they call it D, so minus this 4.2 magic number they came up with, who knows how, plus D, the 68. Okay, so that's a sine equation. I would say in real life, it's always so much easier to use cosine that I would say unless they specifically give you that middle value, you're going to have to guess it. And that makes me feel uncomfortable. It's not very exact. It seems very, I don't know how they got that kind of thing. So about 98, 99% of the time, if it's sinusoidal, I'm going to model it with a cosine. So let me do that here so that you can figure out how to do this more elegantly and correctly without having to wonder, well, how did I get 4.2? Okay, so let's say we use cosine instead. The amplitude is still 14. So we're still going to use A equals 14. The period isn't any different. So all of that thinking we did about A and B, that's all the same thinking. So I'm just writing these down as if we thought through them again, but we didn't. C will be different, and so I'll come back to that. And then D, well, the middle is still at 68, so D is still 68. So the only change is about the C value. So in this case, we're going for a shift, because remember cosine is 0 is at the high. So for cosine, our C is how far did we shift to the right to get to this high value. So the high value is 82, and that happens in July. That's month 7, right? So this is month 7 that it's at the high value of 82. So I'm going to shift 7 to the right, which means C is 7, positive 7. So the equation for that, using cosine instead, is 14 cosine of pi over 6 times the quantity x minus 7, which I feel very much more sure about because it's an actual data point, plus 68. Okay? And if you had a graphing calculator and had that stat plot in there, you could type in to your y equals and graph the sine and the cosine. They should be pretty close to the same thing. And see that it won't match the points exactly, because remember, real data is somewhat messy. So the real data points, I don't know exactly where they fall, but that you may have some that hit and some that are kind of close, right? I'm just making up stuff. And that's going to happen. Real stuff is messy, but this curve should pretty closely approximate it if you were to graph this. So using those techniques, we can find an equation for the sinusoid. And again, I think cosine is a better idea than what they did, but I guess I'll just live with it. And in part B, that's what they want you to do, is to actually graph. And so that's really a graphing calculator kind of thing for you to graph that messy thing, that equation, with those data points. So don't do that. If we were in class, and in fact, if we are in class face-to-face, have me do this, and I'll show you what it looks like on a graphing calculator. Since I didn't require you to get one, I'm not going to ask that you do part B, but all that is basically, after you have the stat plot, type in that equation and graph it, and it should be kind of close. Won't be perfect, but it should be kind of close. And it's just to see, oh yeah, we did a pretty good job. That model, that equation, this is what we call a model of the situation. This equation models the situation of temperature, average temperatures in New Orleans over a course of 2 years. We have data for that. So this is a model for the best guess for what's going on. And what that means is, if you had a particular date, maybe 2 years away, that you want to know, well, what would I expect the temperature to be? You could use this equation. Or if you wanted to guess, well, what's the temperature going to be around the middle of May? Well, that would be 5.5, because May is month 5, and 5.5 would be halfway between May and June. So you could use this equation to make a guess. Now, is that perfect? Oh my gosh, no. And reality happens, and it's not exactly what you would have expected. I mean, you can listen to daily guesses that they make about temperatures, and then they're wrong a lot of the time. So it's a model. It's not what's really going to happen. It's not a crystal ball. It's just our best guess mathematically, based on historical information of what's happened before. We kind of expect the same thing to happen again. But will it be that perfectly? No. All right, that ends this lesson. I will see you in class.